examples. So our first example here is we're just going to get some practice using the sine and cosine of 2x formulas, the double angle formulas, to find the sine and cosine of 2 pi over 3. So even though 2 pi over 3 is a common value, hopefully you can work out the sine and cosine of 2 pi over 3 without using the double angle formulas. We're going to try them out using the double angle formulas, and then we'll just check that the answers we get agree with the values that we know coming from the common values. So we'll use that as a check. We won't use that at the beginning. We're also going to use all 3 of the formulas for cosine and just check and make sure that they all work out and that they all agree with each other. So let's start out by remembering those actually 4 formulas. Sine of 2x is 2 sine x cosine x, and cosine of 2x is cosine squared x minus sine squared x. And here we're being asked to find the sine and cosine of 2 pi over 3. So we're going to use x equals pi over 3. That way 2x, pi over 3. That way 2x is 2 pi over 3. So sine of 2 pi over 3, using x equals 2 pi over 3, it's 2 sine of pi over 3 times cosine of pi over 3. And I remember that the sine of pi over 3, that's a common value. So the sine of pi over 3 is root 3 over 2. Cosine of pi over 3 is 1/2. So the 2 and that 1/2 cancel. And what I get is root 3 over 2. And now let's try the cosine. Cosine of 2 pi over 3 is cosine squared of pi over 3 minus sine squared of pi over 3, according to our formula. But we're going to check it out and see if it works. Now, cosine of pi over 3 is 1/2, so 1/2 squared, minus the sine of pi over 3 is root 3 over 2, so we'll square that out. 1/2 squared is 1/4. Root 3 over 2 squared is, root 3 squared is 3, 2 squared is 4. So we get 1/4 minus 3/4 is negative 1/2. Now there were 2 other formulas for cosine of 2x, and we want to check out each one of those. Cosine 2x is equal to 2 cosine squared x minus 1. And it was also supposed to be equal to 1 minus 2 sine squared x. So we're going to check out each one of those. So cosine of 2 pi over 3, using those other formulas, is equal to 2 cosine squared of pi over 3 minus 1, which is 2. Now cosine of pi over 3 that's a common value. That's 1/2. 1/2 squared minus 1, which is 2 times 1/4 minus 1, which is 1/2 minus 1, is negative 1/2. And let's use the other version, 1 minus 2 sine squared of pi over 3. We're going to use the last cosine formula there. So that's 1 minus 2. Now, sine of pi over 3, I remember that's a common value, root 3 over 2. So we're going to square that out. That's 1 minus 2 times root 3 squared is 3. And 2 squared is 1/4. So that's 1 minus 3/2, negative 1/2. So the first thing we notice is that these 3 different formulas for cosine of 2x, they all gave us the answer negative 1/2. So they do check with each other. That's reassuring. But now let's work out the sine and cosine of 2 pi over 3 just using the old-fashioned common values. So let me draw my unit circle. So there's 0, pi over 2, pi, and 3 pi over 2. 2 pi over 3 is 2/3 of the way from 0 to pi, so there it is right there. That's my 30, 60, 90 triangle. So I know the values there are root 3 over 2 and 1/2, and I just have to figure out the sine and cosine, or which ones are positive and which ones are negative. I know that the cosine of 2 pi over 3, because that's the x value, and the x value is negative, that's negative 1/2. The sine of 2 pi over 3 is the y value, which is positive, so that's root 3 over 2. And look, we worked those out just looking at the unit circle and remembering the common values, but that checks out with the values we got from the formulas there, sine of 2 pi over 3, and each one of the formulas for cosine of 2 pi over 3. So what we were doing there is working out each one of the formulas for sine of 2x and cosine 2x with x equals pi over 3. That separates it out into expressions in terms of sine and cosine of pi over 3, which I remember, so I just plug those in and I get the sine and cosine of 2 pi over 3. All the cosine formulas agree with each other, and they all check with the values that I can find just by looking at a unit circle.